So now we are given a graph here. We are required to solve this graph. So this graph, if you check, it's given in terms of x-intercept. So if you have a graph in terms of x-intercept to solve 4.1.1, you'll use this approach: a into x minus x1. The x1 refers to the first x-intercept, x2 the second x-intercept. So you'll have y equal to, we substitute the x-intercept, you'll have x minus minus 1, which will give us x plus 1, multiplied by x minus 3. So from this you'll have a into, this will be a into x squared minus 2x minus 3. You call this equation number 1. Then you substitute a point that you can find along that graph. You substitute b. Let's substitute b, which is 0 and 6. We substitute it inside equation number 1. So you'll remain with 6 equal to a into 0 squared minus 2 into 0 minus 3. Then you'll have 6 equal to a into negative root of 3. Then you quickly divide both sides by negative root of 3, wherein you will remain with a equal to negative root of 2. If you check, this value of a is in agreement with what we are dealing with. Then you'll go back to, you can call this one equation 2, no problem. You go back to the first equation, you are to substitute this. You will have negative 2 into x squared minus 2x minus 3. Then y is equal to negative 2x squared minus 4, I mean to say plus 4x plus 6. This is the equation, so you can safely write it as f at x. This is, you'll say f at x, therefore f at x equal to negative 2x squared plus 4x plus 6. That's how it's done. Now we are done with this task. Now let's go on to other problems. Let's quickly try to erase this part here. They are saying they want the coordinates of G, which is the turning point in this case. The coordinates of G, which is the turning point. So to find the coordinates of the turning point, there are several methods that can be used for people in your level, since you are in grade 12. So you can find those turning points by doing this. This is 4.1.2. You can find the turning point there by differentiating, or by using x equal to negative b divided by 2a. Then this is x equal to the value of b. You'll have negative into the value of b. It's equivalent to 4, so you'll have negative into 4 divided by 2 into negative 2, wherein we will have negative 4 divided by negative 4, which will give us positive 1. So the x coordinate of the turning point is 1. So now we have to find the y coordinate of the turning point. So we'll have f at 1 equal to negative 2 into 1 squared plus 4 into 1 plus 6 to give us, let me quickly punch in my calculator. When I punch inside my calculator, it's giving me a positive of 8. Therefore, the coordinates of G, it's 1 and 8. These are the coordinates of the turning point. So you are having this one, which is 1 and 8. So now, the main duty is to find the value of M and C. But if you check, M and C, they are found along the straight line. They are talking about the straight line. They are talking of the gradient and the y-intercept. So to find those, let me try to erase this part here. Let me try to erase this part here. You'll just have to pardon me. So now, to find that which that they are talking about there, to find M and C, you have points in that particular line. So we will use point D, which is 1 and which is positive of 3 and 0. We'll also use G, which is 1 and 8. So the first objective here is to find the gradient. Remember, a straight line has got a gradient. So we'll say the gradient of ED, it's equivalent to change in y divided by change in x. So we will have the value of y2, the choice is yours. Let's just use 8 minus 0 divided by 1 minus 3. So which will give us 8 divided by negative root of 2. Ultimately, my answer here, when I quickly punch inside my calculator, I'm getting my answer to be negative root of 4 here. The answer is negative 4. This is the gradient. This is the gradient, the value of m. Remember, those are collinear points. So from this, I can safely say y equal to mx plus c. Then what is the value of m? I already have the value of m, which is negative 4x plus c. So I substitute any point along that line. Let me just substitute g. In fact, let me just take d because it's simple, which is 3 and 0. We'll just have 0 equal to negative 4 into positive 3 plus c. Then c is equal to positive root of 12. Therefore, m equal to negative 4 and c equal to 12. So done. We are done with this question. So let's quickly delve into other questions of interest. So now we are having question number 4.2 here. Then with 4.2, they are talking of hyperbolic functions. So how do we deal with these hyperbolic functions? These hyperbolic functions, we deal with them in this particular fashion. First question they are saying, the first question they are saying, you ought to determine the x-intercepts. You ought to determine the x-intercept. We know that to find the x-intercept, we are having f at x equal to 2 divided by x minus 1 plus 2. So we have to find the x-intercept. To find the x-intercept, you quickly let y to be 0. Remember, f at x is same as y. We are defining a function. So you'll just have 0 equal to 2 divided by x minus 1 plus 2. Then we'll end up with a negative 2 into x minus 1 equal to 2 divided by x minus 1 multiplied by x minus 1. We know that these ones will divide each other, right? We remain with negative 2x plus 2 equal to 2. Then we remain with negative 2x equal to 0. Therefore, x is equal to 0. We don't have to say much about it. So this is the intercept. So now, to sketch the graph for 4.2.2, you need something also. You need something new here. You will also need the y-intercept. You'll also need the y-intercept. But if we are failing to get the x-intercept today, let's try. What about the y-intercept? Let's try to find the y-intercept. Maybe we will determine them. The y-intercept will be y equal to 2 divided by 0 minus 1 plus 2. Wow, we won't be able to determine it. Then this will just give us 0. So y-intercept and x-intercept is 0, all of them. So now we can quickly go and draw our graph. Then to draw the graph, you ought to pay close attention to what you are given or what you are dealing with. You need to check the value of a. So if you check the value of a that we are having here, firstly, we indicate the asymptotes x equal to 1 and y equal to 2. And the shape, since this graph is in the since a is positive, should be in the first quadrant and the third quadrant. This is just a basic shape. So now we are going to draw the graph looking at the values that we are given currently. We are going to draw the graph looking at the values that we have currently. So now I'm not going to write those values, but let me try to write them. Hopefully it's understandable to you. So now, first of all, we ought to plot the asymptotes. We have to plot the asymptote. So in terms of plotting the asymptotes, we are having one at x equal to 1. So x equal to 1 is plotted vertically. Then y equal to 2 is plotted horizontally like this. Now, they are saying when you plot this graph now, we are having the x-intercepts here and we are also having the y-intercept. So our graph will be like this. This will be our graph. This will be our graph. This will be the other terminal arm. And remember, this graph must not touch the asymptotes. It can only approach but not touch. So now, in terms of indicating the intercept, this is 0 and 0. So this is line x equal to 1. This is line y equal to 2. Simple as that. So now they are saying, write down the asymptote of f at x minus 2. So it's more like we are shifting the graphs horizontally. So only one of them will change. Only one will change. So let's look at 4.2.3. Only one of them will change. So we'll have y equal to 2, but we are shifting the graph horizontally to the right. We are shifting the graph horizontally to the right. So we will end up with x equal to 3. This is what is happening here. You can do it algebraically. You can also do it by just looking at the graph. If we are to shift this graph horizontally to the right, it's 1. We are shifting it 2 units, right? It's 1, 2. So the equation will shift from this to x equal to 3. Or you can do it like this. You can just say 2 divided by, where you see x, you are going to write x minus 2. Then you have minus 1 plus 2 like this. This is from the function or the graph that we are given. So this is 2 divided by x minus 3 plus 2. Then this is what we are dealing with. I hope you understand. So now determine the equations of asymptote, axis of symmetry, the axis of symmetry. Now in terms of finding the axis of symmetry, remember we are having two axes of symmetry. We are having the one that has got a positive gradient. We are having the one that has got a positive gradient or m greater than 0. This is 4.2.4. We are also having that one that has m less than 0 or a negative gradient. So we'll start off by saying y equal to x plus c we substitute here. We use the point of intersection here, where the asymptotes intersect. It's when 1 and 2 intersect, right? So we'll have 2 equal to open bracket 1 plus c, then 2 minus 1 equal to c. c is equal to 1. Therefore, y is equal to x plus 1. This is the axis of symmetry. Then the second one, wherein we have got a negative gradient, will have y equal to negative x plus c. Then we will have 2 equal to negative into 1 plus c. Therefore, c is equal to positive 3. Therefore, y equal to the value of x is negative x plus 3. So if you check whatever that I've written here, it does make sense, because we are saying the y-intercept for the one with the positive gradient, it will pass along this line here. It will pass along. So it's something like this. This is the one that has got a positive gradient, is this one. Then we also have this one that has got a negative. So this one, we are saying it will cut the y-intercept or the y-axis at positive root 3. So it will have something like this. It goes like this. All of them, they must pass through the intersection of the asymptote. Now let's proceed. Now we also have the exponential functions here. So now in terms of the exponential functions, which was question 5. So now they are saying determine the value of b if you are given a point. We are having f at x equal to 3 multiplied by b exponent x plus 2 minus 2. So they are saying you must find the value of b. So that point that you see is the one that you need to substitute. So where you see f at x, we write it as y. It's 79 equal to 3 multiplied by b exponent x plus 2. But where you see x, you need to write something. This is 1. Remember, we are substituting something here. It's 1. It's 1 plus 2 minus 2. I said we are substituting 1 and 79 inside the original equation. So we'll have 79 equal to, just to rewrite it, b exponent. Then we are having 1 plus 2. This is exponent of 3 minus 2. So we'll have 79 plus 2, which will give us 81 equal to 3 multiplied by b exponent of 3. We divide both sides by 3. Then we'll have b cubed equal to 27 when you divide. Then you introduce a cube root both sides. Then you will end up with b equal to positive root 3. Then we also have 5.1.2 f at negative 2. This was just basic substitution. So we will just have 3 multiplied by 3 exponent of negative 2 plus 2 minus 2. Where you see x, you just substitute negative 2. So if you are to simplify, this is 3 multiplied by 3 exponent 0 minus 2. So ultimately, we will get our answer as 1, because we know that positive root of 3 exponent 0 is 1. So we are just going to have positive root of 3 multiplied by 1 minus 2. So now from this 5.1.3, write down the domain of f. In terms of the domain, if you check this graph of ours, it's an exponential function, right? If this graph is an exponential function, remember, an exponential function, majority of time, it does not cut the x-axis. It does not cut the x-axis. So what we simply do now, we will safely say it's just x element of real numbers. We don't know which numbers are those. For as long as those numbers are real numbers, this graph will be defined. So 5.1.4, then they are saying they want the range. The graph, obviously, it will cut the y-axis at a particular point. So now, with regards to this one, we are going to have our, it's just a depiction of how the graph might look like, or how it might go about. It's just a depiction, right? So let's say this is our line y equal to -2. If we are saying a range, we want values of y for which this graph will exist, right? So those values must not be less than -2, because if it is less than -2, they will end up touching. They will end up touching the asymptote, and that's not what we want. So this graph is defined for y element of real numbers, where y is greater than -2. It must not touch. We cannot say greater or equal to. It must not touch. Remember, we said it approaches, it does not touch. I hope you understand in that regard. So now we are moving on to other questions. We are done with the first one. We are moving on to other questions. Now we are having a 5.2 here. Let's quickly deal with 5.2. 5.2.1, they are saying that you must prove that a is equal to 1 divided by 4 given f at x equal to a exponent x. So this is just a task of substitution. It's 1 divided by 2 equal to a exponent 1 divided by 2. So you want to remove the exponent half. So what you simply do is 1 divided by 2 equal to a exponent half. You multiply this thing by 2 divided by 1, because you don't. So what you do on the left hand side, you also do it on the right hand side. So you'll have multiplied by 2 divided by 1. You are having your exponent this side. So you will end up with a equal to 1 divided by 4. So we have done what they said we should do here. So at the end of the day, we have the value of a. So 5.2.2, the original equation now, it's f at x. Sorry, let me just write it here. F at x equal to 1 divided by 4 exponent x. This is the original equation. So now they are saying determine the inverse. So in terms of determining the inverse, what you simply do is you'll say y equal to 1 divided by 4 all exponent x. Then you interchange x and y. Then you'll have x equal to 1 divided by 4 exponent y. Then to find the inverse is f inverse at x equal to the log. You introduce the logs now. The base is 1 divided by 4 exponent x. Exponent x. This is exponent x. So from this, you go on further to say, okay, I'm done with finding the inverse function. So now they are saying calculate the value of x. In terms of finding the value of x, this one, even if you will have drawn the graph first, you will still be in a condition to determine it. But let's just do it like this. Let's calculate it algebraically. But some people prefer using a graph to determine it, because when I drew the graph, I think the answer was 8 when I tried finding the answer using the graph. So we'll say 5, this is 5.2.3. We'll say the inverse, they are saying the inverse must be equal to negative 1 comma 5. Right. Now we will check what is negative 1 comma 5 in terms of fractions, because it seems like we are dealing with fractions here, but it's fine, we'll get to that. We'll have log of base 1 divided by 4 exponent x equal to 1 comma 5, negative 1 comma 5, sorry. So quickly after this, you will say, okay, this is same as log of uh, 1 divided by 4 exponent x equal to this negative 1 comma 5. Uh, it is same as negative 3 divided by 2, because we are dealing with fractions, so we don't want to be in a state that we get to make some errors. So now we will say 1 divided by 4 as the base. Remember, we are looking for the value of x. We say this is exponent negative 3 divided by 2 equal to x. Now, this 1 divided by 4 has to be written in terms of a base and an exponent, so that certain things get to eliminate each other. So we can write this one as 4 exponent negative 1 all exponent negative 2 negative 3 divided by 2 equal to x. So now we will end up with x equal to 2 exponent negative 2 exponent negative 3 divided by 2, then x equal to, these two will eliminate each other, they will divide each other, we remain with the 2 exponent of positive of 3, therefore x equal to 8. That's it, we have the value of x now. So now the preceding question was, it actually required us to find to sketch the graphs. So in sketching the graphs, this will be 5 points, sorry. In sketching the graphs, we'll sketch the graphs like this. Now this is the x-axis, this is the y-axis. Now the original function in this regard, it will take a different route from what we may be used to. If you check, you can simply go to your calculator, you check these things. You'll be like, okay, for the original function, I am having 1 divided by 4 exponent x. As I'm increasing the value of x, what's happening to the value of y? For example, 1 divided by 4 exponent 1, this is 0.25. The second one, exponent 2, you are having 1 divided by 8, which is you can see that as you are increasing the values of x, the values of y are decreasing as you increase values of x. So this is a decreasing function. Also, the inverse must be decreasing. So now you start off by saying, okay, this is the mirror line, this one. This is line y equal to x. This is where the reflection will take place. So now we said that as we are increasing the values of x, the values of y are decreasing. So that basically means that we will have our graph like this. Because yes, we'll have our graph like this. This will be our graph, our original function. This will be our original function, this one. This is the graph of, this is f at x, this graph. So if this is the decreasing function and it is the original function, what's going to happen to the inverse function? Now the inverse function will go like this. This will be the inverse function now. This will be the inverse function. Our inverse function will go like this. Sorry, let me try to erase this part here. Wait a bit, seems like I've damaged everything. Okay, I will try to bring it back. Uh, let's check. So now I will try to draw the graph so that we develop a common understanding, all of us. So our graph will go like this. Our graph will be something like this. This will be the graph. This will be the inverse. This is the inverse function. So this will be 1 and 0, and then this one here will be 0 and 1. This will be 0 and 1. So this is the graph. Now